Good morning. Good morning.
Good morning.
Good morning.
How are you?
Good morning.
Okay, fine. I'm fine. In our previous time, we have seen in our physics Zoom class, we have seen different subtopics. Our subtopic was measuring volume of liquids. How we can measure volume of liquid we have seen. Under that, we have seen about the properties of volume. For example, volume of liquids. In case of volume of liquid, before that, liquids are they do have definite volume, but they do not have definite shape. That means they do their own take their own volume, but they do not take their own shape. So they take the shape of their container. And we have seen the relationship between units of volume, especially the common units of measuring volume of liquids is liter. We have seen the relationship between units of volume too. So depending on that, or depending on our previous lesson, we are going to see some examples. After that, we will see how we can measure the volume of an irregular shape as well as the density of objects or bodies and the volume of the density of liquid as well as the density of an irregular shaped body. So let us see example which concerns with our previous lesson. For example, if you see example number 1, express 1.75 meter cube in liter milliliter. For example, this one is depending on what? Depending on the relationship between volume of liquid or the units of volume of liquid. How we can measure volume of liquid? We have seen. Therefore, there is some relationship between volume, relationship between units of liquids, units of liquids. So let us see this example. What's given for you? Some volume is given for you. How many? 1.75 by meter cube. So the required one is in case of A. In case of A, let us see on this screen A only. Volume in what? In liter. Volume in liter is how many? Volume in liter is how many? So to do this one, you must know the relationship between meter square, meter cube, and liter. What's the relationship between them? Depending on our previous lesson, what's the relationship between them? What about 1 meter cube when we compare with liter? How many? How many? How many liters?
1,000 liters.
1,000. Excellent. 1,000 liters. So the given volume is in meter cube. Therefore, we must write in the side of meter cube. Therefore, what about 1.5 meter cube when we express by letter? You can represent instead of this one by variable or by question mark. Let us symbolize by x or represent by variable. So when we multiply crisscross, we will get from this expression 1.75 meter cube times 1,000 liter over the prefix of x is 1 meter cube. Therefore, when we divide both sides by meter cube, we will get x. Then 1 divided by 1 meter cube. Meter cube cancelled by meter cube. Have you seen? I think it is visible. It is clear and visible.
Yes.
So this one, 1.75 means if you want, you can change this one in fraction. When you change 1.75 into fraction, what you will get? 175 over 100. Or when this zero cancel, this decimal point come between 7 and 5. Again, when you cancel the next zero, the decimal become as the end point. That means 175 times 10. Therefore, how many? 1,000.
750.
750 liters is your answer. Your answer. Therefore, 1.75 meter cube is equal to 1,750 liters. Okay. And then if you change 1,750 liters into meter cube, you will get the first one 1.75 meter cube. Okay, 1.75 meter cube. I think this point is clear for you. Clear?
Yes.
Clear or not?
Yes.
Yes.
So, depending on this one, you can change the given meter cube into liter. The volume given for you in liter, you can change into meter cube. In case of B, you can change this one into in different way. For example, under solution of B, 1 meter cube, how many milliliter? How many milliliter? If you change this one, how many milliliter? Do you know this one?
5 million.
Yes. How many
1
milliliter?
billion. 1
One?
billion.
1
Billion.
milliliter. It can be, let us see, 1,000 liter. But 1 liter is equal to 1,000 milliliter. Therefore, if you express this one into milliliter, 1,000 times 1 liter. Instead of 1 liter, you can insert times, sorry, there is no this decimal, milliliter. When you multiply, you will get 1 million, sorry, milliliter. Therefore, 1 meter cube is equal to how many milliliter?
1 million.
1 million
1 million.
milliliters. Therefore, 1.75 meter cube, how many milliliter? We don't know. Let us multiply plus cross. What you will get from this explanation or from this equation? What you will get? Yes, when you multiply, what you will get? How many milliliter you will get? Try.
1,750,000.
Yeah, it can be. Let us see together. By the way, what is your name? Tell me.
Barakat.
Okay, thank you, Barakat. Let us see together. 1 million milliliter over the prefix of your question mark or variable, 1 meter cube. 1 meter cube cancel again by 1 meter cube. The unit left for you is milliliter. Therefore, look, when you cancel 1 0, this decimal point come between 7 and 5. The next 0 come between this one. So how many do you have 0? I think 4. 1, 2, 3, 4. 1 times 175, 175. Add 40. Your unit is milliliter. 1 million 750 milliliter is your answer. Your answer. Therefore, 1.75 milliliter is equal to how many liters? Mr. Nas. How many, Mr.? Yes, how many? How many?
1,750,000.
Yeah, 100, 750 million. Yes. Do you have question on these points? Do you have question on these points?
No. No.
No.
You must know not only this one, by another form, it can be given for you in different units, so you can interchange depending on the relationship between units of liquids, units of liquids, units of liquid. Let us proceed to another subtopic, measuring volume of an irregular shaped body. Do you remember how we can find in our previous time the volume of irregular shaped body, especially solid body? For example, if you wanted to find, take this one is as a stone. If you take this one is as a stone or some solid, you can define the volume of this one in for the formula for the solid. You can't find because of it don't have regular shape. Therefore, we can find the volume of this one in different way. Especially, we will see in two methods. In short, to measure the volume of regular shaped body, we use one of the two methods. We do have two methods. Let us see one by one. For example, the volume of a regular shape can be found by the displacement of water provided to the solid. For example, if you do have some cylinder and you add your pour some water to here, H2O, water, and if you displace stone or some solid matter, in this case, the volume of this water become increase. The volume of this water become increase. Therefore, the first one, for example, you can say this one is volume 1. After you add this one, you make or you donate as volume 2. Volume 2. Sorry, this one is volume 2 minus volume 1. Volume 2 minus volume 1. So when you talk about this equation, the V general one is volume of irregular shape, volume of irregular shaped body or solid. Volume 1 is volume of water, the first water which is exists in this cylinder. Volume 2 is volume of water and the solid irregular shaped body. When you insert or when you add, in this case, the volume of this water become increased. So by volume is equal to volume 2 minus volume 1. The general or the second volume minus the first volume is the volume of an irregular shaped body. An irregular shaped body. So you can find the volume of regular shaped by this method. The second one is you can find by you use also measure the volume of regular shaped body by using displacement method. In this case, the volume of the overflowed liquid is equal to the volume of solids. Simply, they are similar. If you see this one in detail, it is similar. So, to find the volume of a regular shaped body, we must use this one. You must use this method, or by entering into water and the second volume minus the first volume. The second, when we talk about the second volume of water and or liquid plus volume of irregular shaped in one container. So the volume 1 is volume of water or the first volume of a body. Okay, so by using this one, we can find the volume of body, the volume of body. I think it is clear for you again. Clear?
Yes.
I think it is clear.
Yes.
So, if this point is clear for you, let us see how we can measure density of a body. Density of a body. For example, under physics and the measurement, we have seen how we can measure area of different bodies. We must use different formula. Again, for measuring volume, we must apply different formula again.
No.
And let us proceed to how we can measure volume of, density of a substance. How we can measure density of substance. By the way, what is density? What's the definition of density before we are going to how we can measure density? What is measure density itself? Density is what? Density.
Density is the amount of mass in a unit volume.
Yeah. When we talk about density, it is the condensity of a matter, or for example, density is amount of the amount of mass per unit volume, or in a unit volume, or the ratio of volume to mass to volume. That means mass divided by volume. Mass divided by volume. Ratio means divide, or the division between them. So density is the amount of mass per unit time, or the amount of matter. You know, we have seen, you know about definition of mass itself again. So you can define this one in another term if you want. So the symbol for density again, the Greek letter, what we call rho. Maybe this one is, you can write as this one, rho. It is not P. It is not P. So read as rho. Greek letter like beta, alpha, gamma, and etc. And etc. The symbol for density is from the Greek letter, what we call rho, density, symbolized by rho. Density symbolized by the Greek letter rho. So density is equal to mass divided by volume. Mass divided by volume. From this one, mass is equal to, from this equation, mass is equal to, you multiply crisscross again. Mass is equal to?
Density times volume.
No one? Are you Barakat?
Yeah.
Okay, thank you, Barakat. Mass is equal to, mass is equal to density times volume, and from this one, volume is equal to, volume is equal to, yes,
Mass over
mass over
divided by density.
Mass over density. Mass over density. Let us see the SI unit of density. The SI unit of density is kilogram per meter cube. This comes from, this is one of the derived units. One of the derived units, because of density is a derived physical quantity. Density is a derived physical quantity. So we get kilogram from what? From mass. And the meter cube, the SI unit of volume. The SI unit of volume. So therefore, kilogram per meter cube is mass over volume again. The SI, when we talk about this SI unit, it is the SI unit of density, the SI unit of density. So again, when you multiply crisscross again, kilograms equal to, when you multiply, you will get, for example, mass is given for you in kilogram. For example, mass is equal to density times volume. Let us insert this SI unit, kilogram per meter cube times meter cube. Meter cube is cancelled by meter cube. The SI unit of mass is equal to kilogram per second. Have you seen? When you calculate physics, you must remember it is SI unit because of at the end you will express the given substance or the given physical quantity by its unit. It gives for you by itself. If you apply it is equation correctly. It is equation correctly. And when we talk about, you can read this one from your text. Different materials have different densities. For example, the density of aluminum is different from density of magnesium. The density of magnesium different from density of iron and etc. They do have their own density. They do have their own density. For example, if you take the density of water, the density of water is 1,000 kilogram per meter cube. So in 1 meter cube, there are, when we measure this mass, for example, a water, there are 1,000 kilogram, 1,000 kilogram. So the units, the ratio of mass to volume give for you density. Give for you density. Again, this point is too clear for you. Yeah? It is visible and it is clear for you.
Yes.
No?
Yes.
Yes.
Okay. The other points we are going to see under density, measuring density of a regular shaped body, especially solid body. Look in this case again. You must know how we can measure, in this case, the volume of an irregular shaped body. Therefore, density of a regular shaped body is equal to mass of a regular shaped body. Maybe in this case, for example, this one wants to explain for you an irregular shaped of solid body which do have certain mass insert in a given solid or water. When you insert or add in that water, the volume of the water become increase or rises. So the volume of an irregular shape is equal to final volume minus initial volume. That means the second volume minus the first one. Volume 2 means final volume, volume 1 means initial volume. Therefore, by applying this one, you can find both it is volume of, or the volume of an irregular shaped body and the density of an irregular shaped body. Therefore, density of a regular shaped body is equal to it is mass divided by volume 2 minus volume 1. Volume 2 means the volume of water and the irregular shaped body. Volume 1 means volume of the water, or the first volume and the second volume. Have you seen? So, for example, in detail, if you wanted to see from this explanation or from this formula, you can find for mass, you can find for volume 1 and volume 2. For example, let us show for you how you can find from this formula mass. Mass is equal to density times, or in bracket, volume 2 minus volume 1. If volume 1, volume 2, and the density of an irregular shape is given for you, you can calculate by applying this formula, that is mass. You can find it is mass by applying this formula. Again, you can find for volume 1, volume 2 again. You can find. Clear or not? Is it clear for you?
Yes.
Yes.
So
Yes.
we have seen under this one how we can measure the generally density of a substance Again, the second one, how we can measure density of an irregular shaped body, we have seen. By applying this formula, we can find density of a body as well as density of an irregular shaped body. Density of an irregular shaped body. Okay, do you have question before I proceed to the next subtopic? Do you have question?
No.
Do you have question? Okay,
No.
if you don't have
No.
question, let us see how we can measure density of a liquid. Density of a liquid. Okay, density of a liquid is, again, it depends on the mass of mass 1 and the mass 2. Look this one. Look this one. For example, when you add a water to an empty container, when you add a water to an empty container, you do have two mass. You do have two mass. The first mass is mass of an empty container. The second one is mass of water. When you measure, generally it is mass, you are measuring mass of an empty container as well as mass of the liquid. So you must know this point again. You must know. For example, to measure density of liquids, you must follow some steps. You must follow some steps. For example, to measure the volume of liquid, the first step is measure the mass of an empty containers. An empty containers. And they denote as M1, mass 1. Clear? The second one, for the liquid, maybe it can be a liquid such as water, oil, and etc. It can be. For liquid to a given volume into a container and measure the mass of the container as well as the liquid together, denote as mass 2. See now, remember, we are measuring density of liquids, So the difference between, what is the difference in this case? Difference means what? Difference. What's the difference? The difference between M2 and the M1 is the mass of the liquid. Difference means, you don't know the difference? The difference between. What's product mean? Difference.
Multiplying.
Okay, product means multiplication or multiplying. What about difference? It shows?
Subtracting.
Subtracting.
Excellent. Thank you very much. So the difference between, that means mass 2 minus mass 1 is the volume of the mass of liquid. Don't forget what we have seen in our previous time. Don't forget, it depends on each other. Don't forget, it depends on each other. So density of liquid is equal to mass of liquid. That means mass 2 minus mass 1. That means mass 2 is mass of liquid and the empty container, and the volume 1 is mass of an empty container. Over volume of liquid. Maybe volume of liquid can be given for you. Mass of empty container may be given for you, and the mass of liquid and the container together, if it is given for you, you can calculate density of liquid. Don't interchange. If such question is given for you, don't interchange with how we can find density of an irregular shape. For example, in case of to find density of an irregular shape, you are going to calculate density of irregular shape by mass of regular shape over volume 1 minus volume 2 minus volume 1. But in density of liquids, mass 2 minus mass 1. They are different, okay? They are different. For example, again, if you want, don't worry about the how we can find the other formula from this one. The product of this crisscross is equilibrium. For example, this one is rho L. This rho L shows density of liquid, okay? Rho L, density of liquid times volume of liquid is equal to mass 2 minus mass 1. Mass 1. So there, this equation is equal again. By applying this one, you can find the volume of the volume of liquid from this equation again. Everywhere in physics, maybe in mathematics, if one equation is given for you, you must know how you can find for the other or for another equation. You must know. Again, before I am going to give one example for you, still now what you have seen is, I think it is clear for you. It is clear for you. Clear or not?
Clear.
It is too clear. It is too clear. Try to practice by yourself. Try to practice by yourself again. Look one example. When an irregular shaped piece of metal is placed in a cylinder and the water level is raised from 30 centimeter cube to 50 centimeter cube. If the mass of the metal is 150 gram, find the density of the solid. That means this solid is a regular shaped solid. So you must apply in this question the formula of how we can find the irregular shape, the density of irregular shape. What is the formula of density of regular shape? What formula we can use? What formula?
M over V2 minus V1.
Excellent. Thank you very much. Before you are going to solve one question, you must know how you are going to solve that question. So by organize this equation, let us see together. Follow me. What's given for you?
Mass.
Volume 1, 30 centimeter cube. What about volume 2?
50 centimeters.
50, I think it's visible for you. 50 centimeter cube. What about mass?
150 gram.
150 gram. For example, in another question, it can be given for you in different units. For example, your mass may be given for you by kilogram. If you want, or if your question asks you as you change into gram, you must know the relationship between them again. This one is, we can calculate as it is. The required one is density of a regular shaped body. As one of you told me now, density of an irregular shaped body is equal to mass divided by volume of water and the volume of water and an irregular shaped body minus volume of solid, or the first volume, final volume minus initial volume. So we can insert now. 150 gram divided by 50 centimeter cube minus 30 centimeter cube. Let us subtract first. 150 gram over how many?
20 centimeters.
20 centimeter or centimeter cube?
Centimeter.
Centimeter cube. Excellent. 1 0 cancelled by 1 0. For example, when you calculate mathematics or mathematical expression, you must use the simple way. For example, instead of you are dividing you are divide 150 into 20. The simple one is 15 divided by 2. I think this one is simple for you. So simplify. Everywhere try to simplify a number. When such equation is given for you, try to simplify for your equation. Okay, 50 divided by 2.
7.5.
7.5.
7.5
What about it is units?
Gram per
Gram per
centimeter cube.
centimeter
gram
cube.
per centimeter cube.
Gram
For
per
example,
centimeter.
we can change this one again. We can change this one again in kilogram per meter cube, but no need of for a moment. Let us check one of them. Let us check one of them. What about it? What was its mass from this equation? What is the mass of the given equation? 150 gram. Let us check for one of them. Check. For example, what's the formula of mass from this one? I have said something in this equation. What's formula of mass?
Density times volume
What's
2
formula of
minus
mass?
volume.
Yes?
Density times volume 2
Density
minus
times volume.
Density times volume.
Excellent. Excellent. Mass is equal to density times volume 2 minus volume 1. What is your density? 7.5
7.5
per centimeter.
Gram per centimeter cube.
What about your volume 2? 50 centimeter cube minus 30
30 centimeter.
centimeter cube. Okay. First, in the bracket, we will subtract. Everywhere when you calculate your mathematical expression, everywhere you must do in the bracket, depending on the body mass group. So 7.5 gram per centimeter cube times how many centimeter cube?
20.
Excellent. 20 centimeter. Look, centimeter cancelled by centimeter. Have you seen? Have you seen? When you cancel this zero, it becomes this decimal point come to end. Therefore, 75 times 2 gram.
150.
150.
Have you seen? Have you seen how we can? You can check by yourself. For example, if it is given for you, such expression as your answer correct or not, you can check by applying such equation. You can check by applying such equation. Okay? Okay?
Okay.
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 I think our time is up. Let us stop on this point. Let us stop on this point. There is one question on your screen as exercise. How can you measure the density of, look, a regular shaped body? Look, a regular shaped body. This one needs concept and a regular shaped body and a liquid. For this question, try by yourself. Still now, this is the summarization of what we have seen. This question summarized for you what we have seen still now. Do you have any question?
No.
Do you have any question? If you
No.
don't have any question, try to read correctly and fluently and practice again and again. Thank you for your participation in our today lesson, and see you next time. Goodbye.
Bye.
Adios. Bye bye.
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 Adios.
Adios.
Amigos.